Hi and welcome back to this course on memories in VLSI. In this video also, we will continue with our introductory discussions on memory and will cover the classification of memories. This video is very important one since some books or presenters may depict this classification differently. But we will discuss and classify the memories exactly how those were developed or invented. The integrated circuit memories are basically classified into two or three main categories. I will show the three main categories here: the random access memory and sequential access memory. And also we have something called as content addressable memory. So you can actually say there are three main categories, but usually the content addressable memory is not referred many times, but there is a type of memory called as content addressable memory. So you might have heard as random access memory as RAM, but RAM is specifically, some people or some books may refer RAM as only for SRAM and DRAM. It is not true. If we understand why the name of random access memory and sequential access memory came into picture, we will understand that the random access memory is broader memory type, which will consist of other type of non-volatile memory as well, such as ROM and different other types. So we'll try to understand what is random access memory. Random access means that the address may be presented to the memory in any order or randomly without affecting the access time to the stored data. So what does it mean actually? So wherever the data is stored, so we know that the data will be stored in different addresses in the memory. So when we access the access time, there will be something called as access time. I supply the data, I supply the address and it returns me the data. The memory returns me the data, and that period of time in between I give the address and the memory gives me the data, that period of time is called as access time. And access time in random access memories will not depend on the address. Access time will be almost absolutely equal to all addresses in the entire memory. So that's why it's called as random access. For example, in random access memories, we have ROM, PROM, EEPROM, EEPROM memories or flash, register files, SRAMs and DRAMs, and your computers nowadays will use SSDs. Those are also actually random access memories. So SSDs are faster than HDDs, you might have come to know. That's because mostly it's random access memory and it's solid state memory, right? The second type is basically the sequential access memory. Sequential access memory store and retrieve data sequentially. Hence, the access time is not constant. It depends on the physical location of the data. So for some addresses, the access time may be lesser, and some other addresses it may be more, because the memory has to traverse through all the other addresses to go to that address, right? So for example, you can take shift registers, because if you want to access the last register in a shift register, you have to go through all the other registers. Similarly, the queues and FIFOs, which are first in first out, LIFOs which are last in first out, or floppy disks or hard disk, which are HDDs in your computers. The older computers had HDD memories, so which are actually slower than SSDs. That's mostly because that it is sequential access. And then we have something called as content addressable memories. So the content addressable memories actually operate like SRAMs in normal condition, which means that if we supply address, it will give us the data, or we can write into the memory by asserting the read or write line and then also supplying the data and the address. But when we want a matching to be performed, it will do that as well. What do we mean by matching? If we give the data, it will give address. So that's the reason why it's called content addressable memory. So if we give the content, it gives us the address. So this is very much essential in some cases, such as database management systems, DBs, right? Or in CPU operations also it is essentially used. So some of the examples are CAM and TCAM. CAM is content addressable memory in a normal one, and we have TCAM, which is ternary content addressable memory, where it will support not only logic 0 and 1, it will support X as well. So these are the type of memories which we will actually going to look into. But now we will discuss some more detail of random access memory, because random access memory is again divided into three types of memories. One is read only, read mostly, and the read write memory. What are read only memories? Read only memories have high storage permanence, but they have low writability, such as ROM and PROM. ROM is read-only memory and PROM is programmable read-only memory. So read-mostly memory can be programmed more than once. These have middle range of storage permanence and as well as writability. If you consider the ROM and PROM, ROM is not at all writable, but PROM is programmable only once. But the read-mostly memories can be programmed multiple times. That's why they have better writability. Read-write memory is classified into three different types: static RAMs, which are SRAMs, then register files or memory arrays, and then dynamic RAM. Well, all are memory arrays, but you can clearly say that register files are one type of SRAMs which are specifically used for some conditions or very high speed situations. These have highest writability and low storage permanence. So if you want to see how the memory tree looks like, this is how it looks like. So you can branch the memory arrays into random access memory, serial access memory, or sequential access memory, or content reducible memory. And you can classify random access memories into two types, which some people call it as RAM or ROM, as you can see. But the more general or more applicable name could be volatile memory and non-volatile memory. And volatile will have static RAM and dynamic RAM, and non-volatile will have mask programmable ROM or programmable ROM, and erasable programmable ROM or electrical erasable programmable ROM, which is EEPROM or flash ROM. Then we have serial access memories, which are shift registers or queues. We will discuss each one of these in detail in this course on memory. So this is all for the classification of memories. Thanks a lot for watching. I'll see you in the next video, and bye-bye.